Hi everyone, we continue our revision on chapter 6, nuclear physics. Okay, let's look at the paper 1. The following equation represents a uranium nucleus decay. You can see this equation. Okay, uranium-238 decay to become thorium, emits electron or beta, and also alpha. As we know that alpha is a nucleus of helium, and beta is electron, and gamma is electromagnetic wave, or in form of energy. Okay, what the value of x and y? So actually this one can be solved by mathematical operation, as we know that the nuclear number left and right must be balanced. Same thing, the proton number left and right must be balanced. So if I try to write in form of mathematical operation, it will become 238, the nuclear number first, equals to 230 plus x times 0, 0 plus y times 4 means 4y. Okay, so from here I get 4y equals to 8, then I get y equals to 2. Okay, now we use the proton number. 92 equals 90 plus x times -1 should be negative x plus 2 times y, 2y. Okay, so from here we get y equals to 2, we get already, so you just substitute here. 2 equals to negative x plus 4. 2 times 2 is 4. So x equals to 4 minus 2, also 2. So means x2, y2. So the answer will be D donkey. Okay. Number 2. Diagram 2 shows series of radioactive decay of nucleus R to nucleus V, R to V. From this graph, actually you can read the value of nuclear number and proton number. For example, R is here, so the nuclear number is 216, or we can write something like this. R is 216, and then the proton number is 84. So the nuclide notation for R is 21684. And then for V is here, so nuclear number 208, proton number 82. Okay. The question need you to find out how many alpha particle and beta particle emitted in this process. So same thing, if I try to write in form of equation also can, or we just can look from here. So let's say R become S. You look at the nuclear number reduced by 4, and then the proton number reduced by 2. R to S here is 2. 4, 2. 4, 2 is the nuclide notation for helium. So we can say that R release 1 alpha to become S. And then S to U, you can see here the nuclear number no change. Proton number reduced by or increased by 4. So increased by 4 normally is beta. Okay, beta. But here is 2, means 2 beta. Okay. Beta is electron, 0, negative, 1e. Means if emit beta, there's no change in nuclear number. But proton number increase by 1. If release 1 beta. Release 2 means increase by 2. So here is 2 beta. And then U to V, again, you can see okay, by 4. And then here is 2. So in 4, 2 is 1 alpha. So from here, we have 2 alpha and 2 beta. That one is by using the graph. If you want to write, also can something like this. 216 R84, 208 82B plus X 42HE plus Y0 negative 1E. So you can make equation like this and then solve just like number 1. Okay, for example, 2 and 6 equals 208 equals 4x. So x or y times 0 is 0. So you have 4x. Okay, 4x equals to 8. Then x equals to 2. Okay, and then use the proton number 84 equals to 82 plus 2x minus y. X equals to 2. So you will get y equals to okay, make sure correct. Okay, to 6, then I get y equals to 2. Same thing. So I have 2 alpha and 2 beta. Okay. C. Okay. Number 3, following represent beta decay. Emit electron, so we call it beta decay, 1 electron. So which of following is correct about element Y? We look at the nuclear number 0, and then here is negative 1. So means for nuclear number, there's no change. No change in nuclear number. So this one should be wrong already. So we just look at B and C. For proton number, of course, there's a change. So no change also wrong. So means there's no other answer is C. Okay, means increase by 1. Okay, so means if this one is, let's say, is 37. I just put one number just to show you only. 10. So this one will be 37, 11. That's why the proton number will be balanced. So we can see for Y, nuclear number no change, proton number increase by 1. Okay. Ini just contoh saja. Jawapan di C lah. Okay, number 4, initial mass of radioactive element 20 gram and half-life 6 days. Which of following statement is true about mass of radioactive element? Okay, jisim awal 20, separuh hayat 6 hari. Okay, what is the meaning of half-life? Half-life is time taken for nucleus to become half. Okay, activity or mass, okay, of the nucleus to become half. The time taken, we call it half-life. Okay, masa diambil untuk jisimnya berubah menjadi separuh daripada asal. Okay, so which of the statement is true? Mana yang betul? Means if after 6 days, it will become half, means 10 gram. Okay, if 6 days before, it should be twice, then this one should be 40 gram. Okay, so 6 days earlier, 40 gram, correct? 12 days earlier, so we must go back 12 days. Another one, so should be 80 gram. So this one is wrong. 6 days after, is 10 grams, so also wrong. 12 days after should be another 6 days, so it becomes 5 grams. So this one also wrong. So answer is A. Okay, dia hanya separuh saja. Kalau before is double. Okay, after is half. Okay. Number 5, half-life of arsenic 18 days. See how, huh? 18 days. Sample contains amount of arsenic. After 72 days, only 10 gram of arsenic remains. Determine initial mass. Okay, so 72 days, how many half-life? Okay, so just a number of half-life equals to 72 divided by 18. So we get 4. Okay, so 4 half-life. Okay, so means if this one is 10 gram, 4 half-life before, we need to patah balik lah. Okay, means 18 days before, it should be twice than this one, right? So 20 gram. So this one will be another 18 days before, should be 40. Another 18 days should be 80. Another 18 days should be 160. So you can see after 4 half-life, initial mass, 160, it become 10 gram. So the initial mass is 160 gram. This is one method. If we want to use formula also can. If we have the n or half-life, number of half-life is 4, so the fraction left will be, the fraction left equals to 1 over 2 to the power 4, which is 1 over 16. Okay, so the fraction 10 gram over initial will be 1 over 16. So we get initial mass will be 16 times 10, which is 110 gram. So this is also can be used if you understand the relationship, which is a fraction left, half to the power n. N is number of half-life. Or you can just use this method. So there are two methods for this one. The dual method. Okay, number 6. Activity sample X becomes 6.25% of its original value after 120 minutes. Okay, from here. Determine half-life for sample X. So from 100% to 6.25, it takes 4 half-life. Okay, and then the total time taken is 120, means 4 half-life equals to 120. Thus, half-life is 120 divided by 4. So you get 30. Half-life is 30 minutes. Okay, so you must understand the question. A large amount of energy released when two light nuclei combine to form heavy nucleus. So proses ini kita panggil fusion, fuse. Okay. Okay, ini ialah fusion. Okay, nuclear fusion. Lighter combine to become heavier is fusion. If you have another one, fission, heavier nucleus, split to lighter nuclei. Okay, ini terbalik ya. Kalau fusion, two lighter nuclei combine. Okay, kalau fission dia split, dia terbelah. Kalau fusion dia combine, dia bergabung. Itu beza dia. Fission and fusion. Number 8, diagram 8 shows beginning of chain reactions. You have neutron bombard uranium to create So it will cause the uranium to become unstable and split to two. So we call it, this one is fission process, nuclear fission. Okay. From here is strontium and xenium. A chain reaction takes place because, why? As you can see, the process fission at the same time also emit neutron. Okay, there are 3 neutrons here. So these 3 neutron, if nothing happened to the neutron, this neutron again will bombard another uranium. So you can see instead of just one fission process here, after one fission, it will cause another 3 fission to occur. Can you imagine if this one uh, occur, so at the same time this one will emit another 3 neutron, and this one 3 neutron, and here 3 neutron. Now after the second fusion you have another 9 neutron. Imagine how can this 9 neutron suddenly produce another fission process and emit more neutrons. So if uncontrollable, it will produce large amount of energy, because one fission at the same time will release large amount of energy. If uncontrollable, this one is very dangerous. So this process that cannot be stopped here due to the neutron that emitted every time the fission occur. So we call it chain reaction. Berantai lah, makin tambah berantai. Chain reaction. Okay, so a chain reaction takes place because, okay, so you can see from here, number of neutrons released continuously multiplying as time increases. Okay, nampak tak? Okay. Okay, number 9, thorium-228 decays by emitting alpha particle. So this is alpha. Alpha is 42He. So you have thorium, the value of nucleus, mass of nucleus, thorium and radium given in U. Okay, atomic mass unit. 1 U is 1.66 times 10 to the power negative 27 kilogram. So why they state in U? Because the size or the mass of the nucleus is very, very small. So easy to state right in atomic mass unit. Calculate mass defect. Okay, according to Einstein, for this activity, for example, we have initial mass, which is before. Okay, and then after is the final mass. If you total up the final mass and the initial mass, we can see that the final mass is smaller than initial mass. Why? Okay, actually the mass should be constant. Patutnya sama lah. Tapi kenapa final punya lebih rendah? So we can see there is loss of mass. Kehilangan jisim. Where does the mass go? According to Einstein, based on formula E equals to mc squared, the mass that lost or mass defect changed to energy. Because at the same time, there are large amount of energy produced. So where does the energy come from? Come from the mass defect. So how to calculate the mass defect here? M equals to initial mass minus final mass. Okay, so from here we just total up. Initial mass is the thorium. So M, do not round off, you just copy back the value that given here. Okay, minus radium plus alpha is already given here. So 227.97340 U. Okay, so what we get here? 0.00589 U. Okay, so this value in atomic mass unit you convert to kilogram. Multiply 1.66 10 to the power negative 27. So you will get the answer will be A. Okay, so this is we call mass defect. The unit is kilogram. Okay, if they want you to calculate the nuclear energy produced, you just use the formula E equals mc squared. This is mass defect and c is speed of light. Okay, meter second negative 2. So you will get amount of nuclear energy emitted. Okay, number 10. During a nuclear fission, amount of energy released given in MeV, mega electron volt. Calculate mass defect in the nuclear reaction. Okay, so use the formula E equals to mc squared. Okay, 1 mega EV equals to 1.6 times 10 power negative 13. So you need to convert to joule dulu, tukar pada joule. So 1.03125 10 power negative 16. Dia punya mass multiply 1.6 10 power negative 13. Okay, so you will get E, E. So how to get M? M equals to E divided by C squared. So M equals 1.03125 times 1.6 10 power negative 29 divided by 3 times 10 power 8 to the power 2. Okay, for question number 10, you cannot find the answer. Why? I think the value is good. Given is wrong already. But you try and see, check the value of 1 mega EV. So the answer should be C. Check. think it's correct already. Yeah? So this is the method. You will get your answer in kilogram. Okay, the value may be something wrong somewhere, but the method is like this to get the answer. Okay, we get section A, paper 2, number 1. A radioisotope sample containing 200 gram of iodine 131 undergoes decay process. Half-life of iodine 131 is 8 days. What is the meaning of half-life? The keyword must be time taken. Okay, the time taken for the activity of radioisotope to become half. Okay, masa diambil untuk aktiviti nukleus menjadi separuh daripada asam. Okay, give one reason why iodine undergoes decay process. Okay, normally decay process occur because nucleus is unstable. Okay, iodine 131 is unstable, will decay to become stable. Okay, the nucleus not stable, that's why it will decay to become stable. Calculate mass of iodine after 32 days. Given 200 days and half-life 8 days. Initial mass is 200 gram. Half-life 8 days. Okay. For time taken 32 days. The number of half-life is 32 divided by 8, means 4 half-life. So mass of iodine after 32 days M equals to the fraction left is 1/2 to the power 4 multiply initial mass, which is 1/16 times 200. So we get is 12.5 grams. So this is one method. Or you want to start like this. Okay, 200 become 100 become 50 become 25 become 12.5. So means after 4 half-life, 200 will become 12.5 grams. So the mass of iodine after 32 days, 12.5. On diagram 1, sketch graph to show decay process of iodine 131. Okay, from 200 become 100. Okay, 100 become 50. 50 become 25. Okay, so for 200 become 100. Let's say I mark as 8, 16, 24, 32. Okay, 20 to become 8. So this is the first point. After 8 days is 100. After 16 days, 50. Okay, 24 days, 25, 32 days, half of this one is 12.5. Initial mass 200. So if you draw the graph, it will become like a curved line approaching x-axis but never cross x-axis. Okay, so we get this one, we call it decay curve. Okay, question number 2. Diagram 2 shows activity time graph radioisotope potassium 42. This radioisotope emits beta particle and used as tracers to measure quantity of salt in human body. Okay, look at the graph, decay curve. This one we call it decay curve. Okay, soalan, state characteristic of beta particle. Beta particle is electron, so one characteristic is negatively charged. The charge is okay, based on diagram 2, determine half-life of potassium. Okay, show on the graph how you determine the half-life. Okay, we go back to this one. Initial one is 1600. Half of 1600, okay, divide by 2, it becomes 800. So use ruler and pencil, you just draw a dash line like this. And then go down here to read the value of time. Okay, so you have 11, 12. Maksudnya 12 hours. Okay, write down here 12. Show in your graph, on your graph how you determine the value. You get 1 mark from the graph and 1 mark for answer. C, based on half-life, state why suitable to be used as tracer. You can see the half-life is about 12 hours, so quite short. So it's suitable for the process. Okay, in medical, maybe require about 8 hours, okay, or 6 or 8 hours. So it means it's suitable to be used tracer with short half-life, enough for the process. Too short also cannot. Okay, so we can say, okay, potassium has short half-life. Which is safer because it does not stay long in the patient body. Mark. Calculate time taken for radioisotope to reduce 1/8 from its initial activity. The fraction become 1/8. 1/8 actually is equals to half to the power 3. So means number of half-life is 3. Okay. Just now half-life is 12 hours. So the time taken is 3 half-life. So 3 times 12, we get 36 hours. Okay. Number 3, name the type of radioactive decay. So this one emit alpha, nucleus of helium. So we can say it's alpha decay. Okay. Why does radioactive decay occur? Same question just now, because the nucleus is unstable. Sebab dia tak stable, so dia nak jadi lebih stable, so it will undergo the decay process. So we have 3 types, alpha, beta, gamma. Okay, we call it decay process. Okay, this one diagram or table, atomic mass unit of 3 elements. We have radium, radon, and helium. Additional information, determine mass defect in kilogram. So you need to total up before and after. Okay, radium, radon plus helium. Okay, so before you have this one, after you have this one. Okay, this total for after is 226.021. Okay, so means the mass effect is 226.025 minus 226.021. So you will get 0.004 U. Okay, so N equals to 0.00. How many zeros is now? U. So you convert to kilogram, 0.004 times 1.66, 10 power negative 27. So you will get the answer in kilogram, which is 6.64, 10 power negative 30 kilogram. Okay. Calculate energy released from the radioactive decay. So use the formula of Einstein formula. E equals to mc squared. You can check this formula. Mass effect 6.64, 10 power negative 30. Speed of light 3 times 10 power 8 square. Okay, so you will get the answer 5.976, 10 power negative 13 joule. This is your answer in joule. Okay, number 4, diagram 4 shows simple nuclear reactor where nuclear fission occurs to generate energy. So ini adalah reaktor nuclear. Okay, what is the meaning of nuclear fission? Okay, the heavy nucleus split to two lighter nuclei. By emitting energy. Nuclear energy. Yeah? State transformation of energy involved in the system. Okay, untuk reaktor nuklear, dia punya energy change tu macam mana? Kita ada heat energy, produced by the process, will heat up water to be and change it to steam, and then it will turn the turbine. The turbine will cause the coil to rotate in the magnetic field and produce current or induce EMF by induction. Kinetic energy and become electrical energy. Okay, this is what happened in nuclear reactor. Give one advantage using nuclear reactor as energy generator. Okay, no air pollution. Dia tak ada pembakaran, dia tak ada air pollution. By dust, kita tak ada. Okay, and then dia punya long lasting use. Normally the long half-life nucleus will be used, or radioisotope, so that it does not need to replace for longer time as a safety measures actually. So this is advantage of using nuclear reactor. So how nuclear fission in the reactor can be controlled to generate sufficient energy? To control the chain reaction is something to do to the number of neutron emitted. If we can control the number of neutron, means we can control the number of fission process occur. So to control the reaction, the number of neutron bombarded to the uranium must be reduced. Okay, reduce the number of neutron. Which bombard the uranium. The neutron used is the slow moving neutron. So what we use in this case is graphite moderator to slow down the neutron is the control. For fission process, we need to use graphite moderator to slow down the neutron. Then the slow moving neutron bombard uranium to produce fission process. And then to control the number of neutron, so we can use boron. Okay, boron rod to absorb excess neutron. Okay, kita tak nak terlalu banyak so that we can control the nuclear fission. Okay, 3 markah. Part C, so you have nuclear fission of uranium-235 bombarded by 1 neutron, so it split to become barium and krypton, release 3 neutron and energy at the same time. So given the mass in atomic mass unit, calculate mass defect and then energy release. The same question actually, so I think I don't want to discuss this one. You just total up mass before and then you total mass after. Final. So the mass defect equals to mass initial minus mass final. So your answer in atomic mass unit, you convert to kilogram, multiply with 1.66 times 10 power negative 27. Okay, so you will get mass defect here. So mass defect you get in U first, and then in U you multiply dengan 1.66 10 power negative 27. So you will get your answer in kilogram. Okay, and then the same goes to part 2. Energy E equals to mc squared. C is 3 times 10 power 8. So just substitute mass in kilogram, multiply C, 3 times 10 power 8 squared. So your answer will be in joule. Okay, you can try and see the same formula. Okay, for the section B, we have 2 decay curve, 1.1 and 1.2. What is meaning of radioactive decay? Unstable nucleus, they decay by emitting radiation. 1 mark. Process of an unstable nucleus become stable by emitting radioactive or radiation ataupun radioactive radiation, sama. Okay, based on diagram, compare shape, highlight apa yang you nak compare, shape, way or activity changes with time taken for activity to become half of the original activity. So sini ada 3 markah. Name the time for the activity to become half. Okay. Kita cuba dapatkan berapa dia nak compare shape, way changes its time and time taken to become half of original activity. 5 markas ni. Okay, both have a curve shape. Okay, pertama, both graph 1.1 and 1.2 are curve shape. Number 2, wait, I just make a space so that I can write in a second. Untuk this space for you to write the answer. Okay, graph in 1.1 is steeper than in 1.2. Lebih kita panggil dia curam. Okay, number 3, activity of both graph decreases with time. Okay, both sama. Then number 4, okay, we look at here the time taken to become half. This one is 5 minutes. This one is 8 minutes. So it means 1.1 is shorter. The time taken to become half in 1.1 is shorter than 1.2. Okay, don't mention the value. Don't state time taken in 1.1 is 5 minutes, time taken in 1.2 8 minutes. That one is not compare. Yeah? We're just stating only. Okay, so we have 4 only. So the last mark, name the time for the activity to become half. So the time for the activity is called the time taken to for activity to become half is known as half-life. Okay, nampak 5 markah, 5 point. Okay, B, type of nuclear reaction. So ini adalah splitting. So ialah fission. Fission juga ni. Okay, so name the type is nuclear fission. Don't write answer below the question for section B. You have another space for you all to write. So write in the space provided. I write here so that easy for me to refer to the question. Okay. Explain how nuclear energy is produced from nuclear reaction. 3 marks. Okay, first point, there is mass loss before and after the reaction. the mass loss or mass defect will change to nuclear energy. According to Einstein formula, nuclear energy E equals to mc squared. You can define the formula. M is mass defect, C speed of light. Okay, complete. Okay, you compare before and after. There is mass loss. Mass loss also known as mass defect. According to Einstein, the mass defect will change to nuclear energy. So you can calculate the nuclear energy by using the formula E equals mc squared. M is mass defect, C is speed of light. Part C, diagram 1.4 shows generation of electrical energy from power plant that use coal. Okay, pembakaran guna coal. Okay, you are required to suggest modification to convert coal power plant to nuclear power plant to produce clean and safe energy. Coal is not, it will cause pollution actually. Pollution because there's a lot of dust produced and maybe smoke, a lot of smoke that will cause pollution, air pollution. So you want to use nuclear power plant which is clean and safe energy. So describe modification aspect needed as fuel, important component in nuclear core, safety precaution to prevent leakage. 10 marks. Okay, kita tengok soalan ni. Ini adalah soalan daripada section C. Okay, masukkan semua aspek. The fuel, okay, fuel use. Kita ada control rod. Kita ada moderator rod. We have the wall of reactor nuclear. And then one more cooling agent. Okay, so the characteristic. So actually this one is section C, so it should be here, right here. Okay, it should be here. Fuel. Okay. Okay, control rod. Okay, moderator rod. You must know the structure of reactor nuclear. Okay, wall of the reactor nuclear. And then the cooling agent. As we know, there are a large amount of heat energy produced. Okay, fuel, we use uranium. Okay, use uranium. Explanation. Okay, to produce nuclear energy through fission process. Okay, control rod, use boron or cadmium. cadmium also can. Boron is to absorb excess neutron to control the chain reaction. Moderator is graphite to slow down the neutron for fission to occur. Okay, wall of reactor must be thicker wall, thicker concrete wall. Okay, prevent leaking of radiation to surrounding. Okay, cooling agent we use water. Okay, kenapa water? High specific heat capacity. Okay, okay, absorb large amount of heat. Okay, on to control temperature of reactor or nuclear reactor. If too hot, maybe it will explode. So we need to cool down or reduce the some amount of energy or heat energy produced during the fission process. Okay. So this one you just give 5 suggestion minimum. If you have more, you can write more. So you will get 10 marks for this question. So for this topic of nuclear physics or radioactivity, I have done. So that's all. Bye.